formula are still relevant. You need to know all this formula here. Okay, so for this part, they are still relevant. And also this one, all right? This is still relevant in this case, all right? Now in this lecture, I'm not going to talk about the integration by parts first, all right? So we will focus on the standard result here and also the standard result for f prime divided by f. Then after that, for next page, which is next two pages, which is page 6, so for the differentiation, all this I covered already. Okay, yes.
Sorry.
Can you let him?
Who?
Sorry, he's in the waiting room.
Oh, okay. Right. Okay, let's continue. Then today we will look at the integration for this part here. All right. So in this lecture, we will focus on all this formula. So this one is in lecture 5. All right. So we will first start with the P3 formula. All right. So I hope all of you still remember the P3 formula that I gave you under integration, if I were not mistaken. All right. So let's recall. This is P3. Right. So the first result that you need to know is we have the integral of f prime of x and then exponential to the power of f of x dx. All right. So I hope all of you can still remember the formula. Whenever I give you the exponential function like this, then you make sure the f prime basically means the differentiation of this f of x, okay? And if it is in front, then you can integrate this and get e to the power of f of x plus the arbitrary constant c, all right? So provided the f prime is in front. Now, if the f prime is in front, but it's not exactly the form yet, probably you have to add some number. Then remember, you have to make some adjustment inside the integral and also outside the integral. So I hope all of you can remember this is the first formula you need to know for this lecture. So now let's look at the lecture 5. Okay, so this one is the lecture 5, and we will look at some examples which are relevant to the result that I have just given you. All right, so let's look at number 1. Yeah, let's look at question number 1. So question number 1, we have the integral of x and then e to the power of x squared. So how do you integrate this one? So example number 1, the integral of x and then e to the power of x squared, right? Now, another way of writing this function is you put in the form of exp, all right? So you can put this in the form of exp, meaning you have x followed by exp and then bracket x squared dx, all right? So you can have this kind of notation. Now, question, I want to find the f prime. So knowing that this one is the f, therefore the f prime means 2x. Now you already had x in front, so you need a 2 there. So this is what I mean by the adjustment. So therefore, inside the integral, you multiply by a 2, and outside the integral, you divide by a.
Yeah, I think he just stopped.
Where's teacher?
Okay, I think my connection again, I think. Okay. So now let's continue. So we have half. So whatever outside the integral, you just copy. So you have half. Then after that, exponential x squared. So you have exp. So you have exp bracket x squared, then the arbitrary constant c. So this is one way of writing the answer. So if you are not familiar with this notation exp x squared, right, then you can also write this as 1 over 2 and then e to the power of x squared. All right, make sure the squared is visible lah. Make sure the squared here is visible and is clear lah. Right, so that is question number 1. Then we move on to question number 2. So let's look at question number 2. So question number 2, I ask you to integrate x squared followed by exp bracket negative x squared dx. All right. So, no, I think it's x cubed. This one is x cubed. All right. So now I need to make sure that the f prime exists in front. So you see, this one is the f prime of the bracket. So make sure the differentiation of the bracket is in front. So if you differentiate negative x cubed, you will get negative 3x squared. So that means you would need to adjust by having negative 3 inside and 1 over negative 3 outside. So therefore, you have negative 1 over 3. Then the answer is exp. Just left with exp negative x squared plus c. So this is the answer. All right. So sorry, not x squared, x cubed. So you have negative 1 over 3. You want to put in this form also can, e to the power of negative x cubed plus c. Up to you. All right. Both can. Now we go to the next one. The next one, question number 3, is one of the example that I have given you long ago in lecture. I think it's lecture 7 or lecture 8 in your P3. So question number 3, do it yourself. Okay. Number 4, also do it yourself.
Yeah, he only
Okay.
has remembered
So number 3,
using
number
his
4,
brain.
that would be your homework. Okay, I will give you the answer tomorrow. Then after that, we look at the next theorem. Now, the next theorem is actually power rule. So this next theorem is quite important. Power rule for integration. Okay, so for the power rule integration, right? I think most of you know that the integral of f prime of x, where f of x has the power n there, dx, this is equal to, now provided the f prime is in front, all right, the differentiation of the bracket is in front, then you can integrate this to f of x to the power of n plus 1
Yeah, again.
okay. Right. So we have f of x to the power of n plus 1 divided by n plus 1 plus c. Now, if you look at this formula, this is actually not applicable when n equals to negative 1, right? Because you cannot have 0 at the denominator. So what happens when n is equal to negative 1? So this is the special thing, right? When n is equal to negative 1, you don't use the power rule. Because when n is equal to negative 1, that would mean you have f prime of x divided by f of x dx. So according to the formula list MF19 that we had earlier, so you can see that you can go back to page 4. So this is the formula. When you have f prime over f, this is actually P3. So you have ln f of x. So we are going to use this. So this is equal to ln modulus of f of x plus c. All right. So this is the situation when n is equal to -1. And this is actually in page 4 of MF 19. In fact, you learn this one in P3. It's the P3 formula. Okay, so this is the special situation when n is equal to -1. Now, let's move on to question number 5. So for question number 5, let's look at question number 5. We have the integral of cos x sine x dx. So how do I do this part? So you see, I can actually take the f of x as sine x. This one is my f. And you know clearly that the differentiation of sine is actually cos, which is already in front. Okay, already in front. So you see, when this is f of x, sine x is a f of x, then what is the power here? The power for sine x is actually equal to 1. So I can use power rule. So when you use the power rule, you will obtain the answer. Therefore, you have sine x in the bracket. You have power 1 plus 1. So therefore, you get 2 and then divided by 2 plus c. Right. So this is the first answer. So you have sine squared x over 2 plus c. Right. Let's say I call this c1, c1. This is one way of doing it for question number 5. Now for question number 5, the second way of doing this is by using, this is another way. So I have cos x, right? I have cos x. Then I have sine x dx. So I have another way of doing this. Now what happened is I let my f of x be cos x. Also can. I let this be my cos x. My f of x be my cos x. Then in this case, you would have f prime as sine x. Okay, sorry, f prime is not sine x, but you can adjust it. You can adjust it to negative sine x. So therefore, you have cos x times negative sine x. So outside the integral, do not forget you have to add a negative, so that this negative cancel out with this negative and gives you positive. So now I have, therefore the result is negative. So the power is still 1 here. So I have negative bracket cos x squared divided by 2 plus c2. So you see, the first answer is correct. Sine squared x over 2 plus c1. The second answer, negative cos squared x. So you can simplify this to negative cos squared x over 2 plus c2. The second answer is still correct. You see, the two of them are actually correct, right? But you may have different c1 and also c2 value. It's okay, right? If this is actually a definite integral means the limits are given. Then you know that the two of them will give you the same answer if the definite integral is given. All right, that means the limits are given. So you see, by using the identity cos squared x equals to 1 minus sine squared x, then you can get back this answer here. All right, so the c1 and c2 could have different value in this case, right? So this is a second way of doing it. Now I have a third way of solving the same problem here. So the third way of solving this is not using the power rule, by using trigo identity. So the method is by using double angle formula. Okay, double angle formula. So you know that the sine 2a is equal to 2 sine a cos a. Most of you know this. Therefore, I rearrange, I would get sine a cos a is equal to 1 over 2 sine 2a, right? So I'm going to use this one. And therefore, now the integral becomes sine x cos x dx. So I change this one to the integral of half sine 2x dx. So therefore, this is equal to 1 over 2. And then you integrate the sine 2x, that would give you negative cos 2x divided by 2 plus C3. Because you integrate the sign, you get negative cos, right? So therefore, the final answer is negative 1 over 4 cos 2x plus C3. So that's how you get this answer. So you see, even though three of them are in different form, but actually they are the same thing. Okay, they are the same thing. So you don't have to worry. All right. So for this question, I show you three different ways of getting the answer. So two of which are using the power rule. The last one is using the double angle formula. Right. Now we go to the next question. So let's move on to question number 6. Question number 6, I think you know what to do. So question 6, you have the integral of x followed by bracket 1 plus x squared. You know that square root means power half. So I change it to the power form straight away because I'm going to use power rule. And the adjustment that I am going to make here will be 2x. So therefore I have to adjust by putting a half in front because this is our f. Okay, so this is therefore our f prime. This is our n. So now keep the half outside. Then you have 1 plus x squared to the power of 3 over 2 divided by 3 over 2. So the 2 here and the 2 here cancel out. And don't forget you have the arbitrary constant c. So therefore, the final answer is 1 over 3. And then you have 1 plus x squared to the power of 3 over 2 plus c. So that's the answer for question number 6. Okay. For question number 7, right, 7. This is what you see, 7. The integral of ln x over x dx. Now, many people know that the differentiation of ln x is equal to 1 over x. Okay, so I'm going to rewrite this one in the form. I have 1 over x followed by ln x dx. I put it in this form. Okay, why do I put it in this form? Because now I can say that this is my f. This is our f. Therefore, this is the f prime. Because the f prime is 1 over x f. So therefore, the ln x now having power 1. I don't write the power means power 1. Okay. So therefore, using the power rule again, I know that this is equal to ln x bracket to the power of 1 plus 1 over 1 plus 1 plus c. Therefore, the answer is half of ln x in the bracket squared plus c. So that is the answer for question number 7. So for question number 8, this is your homework. Okay, question 8, do it yourself. Okay, so far okay? Any problem? Huh? If no problem, then I will move on to the next part. Okay, the next part, which is the the integration involving the hyperbolic functions. This part is new. All right. So for integration of hyperbolic function, integrating hyperbolic functions. So of course, we are now talking about sine, cos, and tanh. All right, sine x, cos x, and tanh x. Now, if you look at the formula list, go to page 6. So I think most of you can see from here that if you are asked to integrate sine x, then you know that the corresponding integral is cos x. Because you differentiate cos x, you get sine x. And then to integrate cos x, you get sine x. Because you differentiate sine x, that would give you cos x. And then for the last one is, if you integrate sec square x, you will get tanh x. Okay, so you have to look at these three formula here. Now, I'm not going to talk about the rest yet. Okay, I'm going to stop up to here today. Okay, so let's talk about sine x, cos x, and also sec square x. So integrating hyperbolic functions. Now, the first one. Suppose that I ask you to differentiate, okay, the function sine ax plus b. So by looking at the differentiation using chain rule, you know that when I differentiate sine, I'm going to get cos bracket. Then I have to differentiate the bracket. And what are the terms in the bracket? Ax plus b. So this is also ax plus b. So when you differentiate the ax plus b, that would give you a. Hence, you get the answer a times cos ax plus b, right? So conversely, so we are now looking at the other way. I can say the integral of cos ax plus b dx. This will give you 1 over a and then sine ax plus b plus c. Okay, so this is the result. Of course, this result is not given in the formula list MF19. All right, it's not given. However, you know that when you are given linear here, when this part is linear here, so you always have this extra factor 1 over a times sine ax plus b. Okay, so I give you one example on how to do this, the differentiation of sine ax plus b. Yeah, sorry, the integration. All right, so for example, I give you example, I give you the integral of, let's say, cos, then I have ln 2 minus ex dx. So when I ask for the integration of cos, you know automatically that this is equal to sine. So you have sine of ln 2 minus ex divided by, so now check what is the coefficient of x in this case? Negative e, right? So you have to divide by negative e because you are using 1 over a divided by a. So the a is actually the coefficient of x. So divided by negative e plus c. So that is the example number 1, corresponding to the integral of cos ax plus b. So please take note, the formula given here is only cos x. So the formula that I give you in this handout here is actually the general formula. Okay, so now we go to the second part. All right, so for the second part, now we talk about the differentiation of cos. Okay, so when I ask you to differentiate cos ax plus b, what do you get? So from the example above, I think you can roughly guess the answer. The result will be a sine ax plus b. So conversely, now I'm talking about the integration. I can say the integral of sine, the integral of sine ax plus b, the integral of sine ax plus b dx is equal to cos ax plus b divided by a plus the arbitrary constant c. So this is the second formula. So this is the second formula, right? So you have to remember to divide by a, right? So for example, let's say I ask you to integrate sine 4x minus 3. Okay, let's say I don't give you x, I give you 4 data minus 3, integrate with respect to data, d data. So integrate sine 4 data minus 3d data. So that would give you equals to, so remember you have 1 over a. So 1 over a in this case is 1 over 4, right? Because the coefficient of data is 4. So 1 over 4, then you integrate sine, you get cos. So you have 4 data minus 3 plus c. So that's how you get the result. by using the standard formula. Okay. Now, the last one, number 3. So formula number 3, if I ask you to differentiate tanh ax plus b. All right. So if I ask you to differentiate tanh ax plus b, so you know that you are going to get a, then you have sec squared ax plus b. Then you know that the result. So conversely, I know that the integral of sec squared ax plus b dx is therefore you have tanh ax plus b divided by a. So the lesson is to tell you that remember to divide by the coefficient of x in this case, okay, plus c. So this is the result, right? So this is the result that you need to remember, okay? So example, let's say now I talk about the integral of, let's say 3 sec squared, and then you have 4 minus 6t dt. All right. So if I ask you to integrate this one, the 3 is just a constant, so you always keep the 3. Then you know that integrating sec square, that would give you tanh. So tanh ax plus b. Hey, sorry. In this case, it's not ax plus b. Tanh 4 minus 6t. So 4 minus 6t, then you have to remember to divide by -6. So multiply plus c. So the answer is therefore -1/2 tanh 4 minus 6t plus c. Okay, so today you only learn a few formula. So I repeat, okay, I recap what we have learned just now. The first one is actually in your P3 formula, the integral of f prime e to the power of f. Provided the f prime is there, you can use the result. Therefore, the result is e to the power of f(x), provided the f prime is there. If the f prime is not there yet, then you have to check whether you can make it into the f prime form by making some adjustment inside and outside the integral. For example, inside the integral you multiply by 2, then outside the integral you divide by 2. Okay? Then the second formula is the power rule for integration. And remember, power rule is powerful. So whenever you see there is this power in the integral, the first thing that you may need to suspect is, can I use power rule? So when you use the power rule, make sure you have the f prime again. So the f prime is there, then you can use the power rule, f of x to the power of n plus 1 divided by n plus 1 plus c, provided your n is not equal to -1. Because when your n is equal to -1, you have to use the P3 formula, page 4 of MF19. The integral of f prime divided by f will give you ln modulus f of x. Okay, so these are some of the examples, and I expect you to go and do number 3, number 4, and number 8 today. You don't have to send me later. I will give you the answer tomorrow. All these are just easy examples, okay? So the next one is to integrate the hyperbolic functions. So I'm talking about the hyperbolic functions, sine ax plus b, cos ax plus b, and also sec square ax plus b, all right? And also the 3 different examples. So I hope all of you can understand the lecture today, and that's all for today. Thank you.
Thank you, sir.
Thank you, Mr. Lee. Thank you, Mr.